Good day, Doc Gonzalez. Good day, everyone. I am Midshipman Gallego Adrian from base Mari 2.1 Alpha, and today I'll be discussing how fluid corrosiveness and the presence of suspended solids affect PID control of pressure measurement and control system. So let's go. Introduction. Fluid corrosiveness and suspended solids degrade sensors' performance and create nonlinear process disturbance. These factors cause control lag, measurement drift, and valve wear, which force a PID controller to constantly fight pulse or signals sluggish feedback, leading to system instability or severe oscillation. Next is impact of corrosive fluids and suspended solids on pressure PID control. So the impact of corrosive fluids and suspended solids on pressure PID control is sets up the overarching topic how harsh fluid conditions, chemical reactivity, and particulate presence impair automated pressure control system managed by PID loops. So next is what is fluid corrosiveness and presence of suspended fluids. Fluid corrosiveness. Fluid corrosiveness is the ability of a liquid or gas to chemically attack, wear away, or damage materials such as metals, plastics, or rubber that come into contact with it. Corrosive fluids react with the surface of pipes, bulbs, pumps, sensors, and pressure transmitters, causing rust, pitting, thinning, leaks, and equipment failure over time. So, it defines the fluid corrosiveness as the chemical breakdown of physical components, metals, plastic, rubbers. Corrosive liquids or gases attacks the pipe walls, pumps, bulbs, and pressure sensors, causing the material thinning, fitting leakage, and mechanical failure. So next is the effects of fluid corrosiveness, sensors, and diaphragm degradation, corrosive media, acid caustic solutions, chloride, attack sensing diaphragms through fitting and stress corrosion cracking. Thinning diaphragms alter mechanical stiffness, causing severe zero shift and calibration drift, leading the PID algorithm to calculate errors. See on coordinates process data. So the effects of fluid corrosiveness sensors, impact of corrosion on pressure measurement hardware, chemical exposure, acids, caustic, chlorides, cause fitting and stress, cracking on thin sensor diaphragms. Changing diaphragm stiffness leads to zero shift calibration drift, causing FADE controller to make correction calculation based on faulty feedback data. Next is bulb trim and seat fitting. Chemical attack on control bulb seats and lugs degrades the bulb inherent flow characterization curves. Internally care across fitted seats prevent Talsnator, causing the Fade integral turn to wind up, trying to reach zero flow at low pressure set points. Chemical degradation on final control elements, attack on valve plugs and seats flow characteristic. Internal leakage fast damage seats prevents proper shut-off, causing integral wind up in the KD controller as it ruthlessly attempts to eliminate residual pressure flow at low set points. So next is presence of suspended fluids. The presence of suspended solids means that a fluid contains small solid particles that are mixed and carried within the liquid but are not dissolved. These particles can remain floating or moving the fluid flow. It's that. So the presence of suspended solids is it defines fluid containing undissolved solid particles carried in the stream. These floating or moving particulates introduce mechanical aberration and physical blockage throughout the process loop. Next is impulse line clogging. Particulates settle in impulses lines, creating physical blockage that severely dampen pressure signals and increase dead time. Erosive wear. High velocity abrasive particles erode control valve plugs and seats, constantly shifting process gain. Next is valve extinction and dead bond. Solid deposition along valve stems increase friction, causing extinction and limit cycle oscillation around set point. So the impulse line clogging, it settling solids block sets lines, dampening signals and increasing process dead time. So erosive wear, high velocity particles erode valve internals, altering process gain. So the instinction and dead bond particulates build up along valve stems, causing high friction, extinction, and continuous limit cycle hunting around the set point. So the next is what is FAD? FAD or proportional integral derivative is a type of automatic control system used to maintain a desired value set point of a process variable such as pressure, temperature, flow, or level. A FAD controller works by comparing the actual measured value with the desired set point and automatically adjusting the system to reduce the difference or error. The basic overview of proportional integral derivative control. A PID is an automated control loop mechanism that calculates process error, difference between a measured process variable like pressure and desired set point, and continuously applies correction to minimize that error. So the next is summary. A PID pressure measurement and control system maintains a constant process pressure by continuously measuring pressure, comparing it with the desired set point, and adjusting a control valve or pump. However, corrosive fluids can damage sensors, valves, and pipelines, while suspended solids can clog sensing lines and wear out control equipment. These problems reduce measurement accuracy, slow controller response, and decrease the overall stability and reliability of the pressure control system. And that's all. Thank you. Again, I'm Richman Galevo, Alpedrian from Miss Mari 2.1 Alpha.